The question here is the calculation of the outstanding balance on a loan. That is the size of your original loan, 800,000, and the question is, how much will you still owe on that loan after a period of 10 years? In other words, at 120 months. Okay, so if we go up here, we can get a reading off our graph. And you can see that you would be owing an amount of 600,000 Rand still. The balance outstanding on your loan has not dropped very much because initially those payments are mostly interest. Only small amounts are going to reduce the capital. When is the balance outstanding half its original value? Well, half its original value would be 400,000 Rand, and that, if we go down to our graph here, is pretty close to 180 months. So what we're trying to do now in today's calculations is at any point on our timeline there being able to calculate the outstanding balance of the loan. Okay, so essentially we're going to use this idea that the outstanding balance is the money owed to that point minus the money paid to that point. So in this case, Mr. Hamish takes out a loan. He takes out that loan of 800,000. It's being paid back. The word amortized means that you will be completely paying back the loan over a period of 20 years. The loan is repaid monthly and accrues interest at a rate of 11.5% per annum compounded monthly. So the interest that we are going to be dealing with is 0.115 over 12, and that's what we'll put in our memory. Okay, determine the monthly installments, and we start 1 month from now. So this is the same as previous videos, so we're going to say the money we owe . 800,000 and the interest, because now I'm just working out my monthly payments, and the interest, so 1 plus A, right to the end of my timeline, 20 years compounded monthly, is equal to my monthly payment, 1 plus A to the power of 20 years compounded monthly, all over A. Okay, so 0.115 divided by 12 equals shift store in memory A. All right, so 800, 1,000, 1 plus alpha A, close bracket, raised to the power of 20 times 12, and that value is 7892441.46, and I am going to store that in memory B. Over here I have 1 plus alpha A, close bracket, raised to the power of 20 times 12, subtract 1 all over alpha A equals, and that value is 925,1010, etc., etc., etc. We do not round that off. Shift store C. And all I'm doing now is dividing what I had in memory B by what is in memory C. So that is alpha B divided by alpha C. And my monthly repayments are 8,531.44. Now this is the new stuff. Determine the balance outstanding after a period of 12 years. So in other words, at this point on your timeline. So your balance outstanding is always going to be the money owed, 800,000, and the interest to that point. After 12 years, compounded monthly. Subtract the payments that you have made up until that point over there. So the size of our payments are 8,531.44. There are multiple payments, so that's our annuity formula. 1 plus a to the power of 12 times 12 minus 1 all over a. So it's all the same interest rate. So we have our 800,000, 1 plus alpha a, close bracket, raised to the power of 12 times 12. I'm going to write it down so that you can check your answers. 315,9095. 95. I'm going to store that in memory B. Now I'm going to subtract this value over here. 8,531.44 multiplied by 1 plus alpha a, close bracket, raised to the power of 12 times 12, subtract 1 over alpha a equals 2625,193.76. And when I find the difference between those two values over there, I get 533,902.18. After a period of 12 years, that is how much money I would still owe.